The Design Challenge is an annual competition for students organized by the Institution of Mechanical Engineers. This year, the task is to complete a robot that can perform specific movements and reaching certain targets. Some of the main rules include a scoring system in which accuracy is key, with a device having a maximum budget of £100, which must be built using available facilities all within 6 weeks. The budget required for all components is equal to £85.90, and the project has been completed by dividing the work between the two members of the group as following: Patrick on the design and engineering, and myself working on the electronics and programming. In the next section, Patrick is going to talk about the design of the project.
As the member of the group responsible for the design of our robot, I was tasked with visually conceptualizing our research and sketch ideas. We began by researching different robots. After researching different robots, we concluded that the mini sumo robot would serve as the inspiration for our design. This led to the formulation of our first design idea. When selecting components for our first design, we made sure to consider quality of life features, for example, swappable batteries, a programmable port, and removable wheels. This has been done so that in the case of faults in the competition, we could service our robot without the use of tools. We further brainstormed issues that we may encounter from an engineering point of view to mitigate problems with our final build. As a result, over the course of this project, our robot underwent many iterations where we made improvements based on problems and new requirements identified. In line with our idea for a compact design, we decided to have our initial dimensions measuring at 100 millimeters by 100 millimeters. For our calculations, we found that the torque required is 0.0086 newtons per meter. But as we are using 4 motors, the torque available to us is 316% of the required value. Our usage for 4 motors was to fall in line with our aim of a fast robot. This resulted in an RPM of 420, which resulted in a surface speed of 0.91 meters per second, which would give us a complete runtime of approximately 13 seconds. Now I will hand you over to Ciprian, who will discuss our choices regarding programming and electronics.
A custom PCB has been created to fit all the components into such a small space. Our circuit uses an Arduino Nano as the brain, together with an L298 motor driver to control all the motors, all based on the data received from the IR sensors. Here, the first version of our PCB can be observed. However, we encountered some issues caused by the noise generated from the sensors and motors. In the second version, we added motors and sensors decoupling, as well as a scotch diode along the line of the power supply, which solved the issues. The total power consumption for the device is 1,386 milliamps, but the battery capacity is 750 milliamps hour, which enables us to have our device run for 32 minutes and with an average runtime of 20 seconds capable of doing 96 runs. In order for the robot to be fully autonomous, a testing environment needed to be created. By using the basic code and tools such as the serial monitor, we have been able to optimize the code, increasing its accuracy and response time to real-time events. Through serial monitor, the needed values to have the robot perform certain events have been found. We're able to identify when the robot is too close to the wall, when the robot is on a certain color band, so that the different movement actions can happen, as well as the PWM values required for this to happen in a perfect straight line, as can be seen on the right side of the slide. With time, and after many iterations, the code would be optimized by transforming parts into functions which would get called when needed, as well as the use of flags in order to simplify loop requirements. We can observe how the initial flowchart got heavily simplified by reducing the commands that needed to be executed, while keeping the exact same runtime. Here, the 4 stages of development can be seen. In the 4th stage, we can see how the speed control negative feedback loop is used to have a straightforward movement so that the robot can do a bullseye. In conclusion, we're able to design and build a compelling robot that performs all the tasks required while also respecting all the rules and staying within the £100 budget. This has been achieved thanks to the many Zoom meetings and professionalism of the team members. With all this said, I'd like to thank you for the time dedicated.